So, you know that feeling you click buy now, and almost like magic, a package shows up at your door? Well, today we're going to pull back the curtain and look at the secret robot armies that make all of that happen. It's pretty amazing stuff.
I mean, think about it for a second. It really is a modern miracle, right? You order one specific thing, and somehow, in just a few hours, it's already heading your way. So how on earth is that even possible? How do they find your single item among literally millions of others and get it out the door that fast?
Well, the answer starts with the sheer scale of the problem, which is just mind-blowing. We're talking about warehouses the size of small cities. I mean, millions upon millions of different products, stored in buildings bigger than a dozen football fields. Finding that one thing you ordered? It's the ultimate needle in a haystack problem. And that's exactly where the robots come in. Okay, so let's jump into our first solution. This is one of the classic workhorses of the warehouse world, the carousel, and its whole philosophy is kind of flipped on its head. Instead of having a person run all over the warehouse to find a product, the carousel, well, it brings the product directly to the person. The best way to picture this is, you know those conveyor belts at sushi restaurants? It's exactly like that, but for products. You've got these shelves that just rotate around on a track, and they bring the exact bin you need right to the person who's picking the order. Super simple, really clever, and it completely changes the game from the old model.
But like anything, there's a trade-off. And you can see it right here. The huge advantage, the pro, is all about space. You can cram these things right next to each other because you don't need aisles for people to walk down. That's awesome. The con, though, it's a big one. You only have one spot to pick from, so you can't just throw more people at the problem to go faster. It creates a massive bottleneck.
Now you might be thinking, okay, to save time, what's the fastest way for it to spin? It seems obvious, right? Just turn it. But what if your order has, say, 3 different items on that same carousel? Do you go clockwise? Counterclockwise? Maybe you go one way and then reverse? When they're trying to save every single second, these little decisions add up. And this is where it gets really cool, the hidden genius of it all. What's actually happening is that the carousel's computer brain is constantly solving a version of the traveling salesman problem. You know, that super famous, super complex math puzzle? It's figuring out the absolute shortest, most efficient route to grab all the items for an order. It's some seriously heavy-duty math, all hidden inside what looks like a simple spinning shelf.
All right, let's move on to our second solution, the A-frame. And if the carousel is all about bringing the shelf to the picker, the A-frame is about one thing and one thing only: pure, raw speed. Just get a load of this thing. Honestly, the best analogy is a giant vending machine on steroids. You've got a conveyor belt running right down the middle, and when a bin for an order comes through, these dispensers on the side just poof, shoot the products out onto the belt. It's wild. So its big strength is incredible speed, but only for certain things, small, uniform items. Think pharmaceuticals, cosmetics, that kind of stuff. But it has a major weak spot, a real Achilles heel. If even one of those little product channels runs empty, the entire machine grinds to a halt. The whole operation stops until someone can come and restock that one empty slot.
And that brings us to the hidden labor. See, the picking part is automated, yeah, but restocking the machine, that is a ton of manual work. First, you've got to move the product from some big reserve storage area. Then it gets loaded into these intermediate flow racks. And then someone has to manually, painstakingly load every single one of those little dispenser cartridges. It's a great reminder that automation doesn't get rid of human work, it just shifts it around. Okay, this is fascinating and totally counterintuitive. A case study found that one facility cut its labor costs by a factor of 3. How? By putting fewer items into the A-frame. Yeah, you heard that right. By only stocking the absolute best-selling, fastest-moving stuff, they cut way down on all that restocking work. It just goes to show, sometimes doing less is actually way more efficient. All right, on to our third and final system. This one attacks a totally different problem: the crazy cost of real estate. Let's talk about the automated storage and retrieval system, or you know what? Let's just call it AS/RS. I love this analogy. Think of an ASRS as a robotic librarian, but instead of books, it's in a skyscraper full of goods. It's this crane-like robot that zips up and down these super narrow aisles, grabbing entire pallets from way up high and bringing them down to an operator.
So its superpower is density. It's all about conquering the high cost of land. I mean, if you're in an expensive area, you can't just build a massive, sprawling warehouse. You have to build up. And that's what an ASRS lets you do. The aisles are barely wider than the products themselves, and the shelves go practically to the ceiling. You're using every last inch of space. Now, to really get the most out of these things, you have to be smart about it. There's what's called a single command cycle, which is pretty basic. The robot goes out, does one thing, either stores an item or retrieves an item, and then comes back. Simple. But the dual command cycle is way more clever. On a single trip, the robot will go store an item, and then on its way back, it'll stop and retrieve another one. It's basically doing 2 jobs for the price of 1 trip. And the numbers really don't lie. Look at this. A system running on those simple single command cycles, it can handle about 34 operations an hour. Not bad. But by using the smarter dual command cycles, that same exact machine can suddenly do almost 42 operations an hour. That is a 21% jump in productivity, just from being a little bit smarter with the robot's travel plans. So we've looked at 3 really different approaches, right? We have the space-saving carousel, the super-fast A-frame, and the super-dense ASRS. So the big question is, how does a company actually choose which robot is right for them?
Well, the truth is, there's no one-size-fits-all answer. It's a really complex balancing act. It all depends. What kind of product are you shipping? Little bottles of perfume or giant car bumpers? How fast do your customers expect their stuff? Is labor expensive where you are? Is land cheap? The perfect robot really depends on answering all those questions for your specific business.
But all this incredible technology and brilliant engineering, it doesn't mean these things are perfect. At the end of the day, there's still physical objects operating in the real world, and sometimes the real world fights back, and it can be pretty funny. Oh man, this story is amazing. So there was this warehouse using carousels for heavy auto parts, and someone decided to load up one entire side of a carousel before starting on the other side. Well, you can guess what happened. The whole thing became unbalanced, and carousel number 29 just tipped over, and then it hit the next one, and the next one, a majestic, slow-motion, domino disaster. Here's another one. A different team thought, hey, let's crank up the speed on our carousel to get more orders out. Great idea, right? Except the boxes were kind of slick, and when the shelves whipped around the corners at top speed, the boxes just flew right off. They went skidding across the warehouse floor like pucks in a hockey game. Just goes to show you, even fancy robots can't ignore the laws of physics. So the next time a package shows up on your doorstep and you're thinking, how did it get here so fast? Now you'll know the secret. You'll be picturing this whole hidden army of robots, sophisticated, silent, and yeah, sometimes a little clumsy, that made it all happen. So the only question is, which one of these robots do you think packed your last order?